And the next question, you're asked a little bit about acids and alkalis and bases. Remember that acids and alkalis react together in neutralization reactions to produce water, and bases are things that can neutralize acids. Alkalis are a subset of bases that can dissolve in water. So a student took zinc oxide, which is the base. All the metal oxides are bases. They all react with acids to neutralize them. And if you take zinc oxide and react it with hydrochloric acid, you get zinc chloride solution. And you're asked to complete the equation below. Right, so you're given the information you need in the question really to do this. So zinc oxide powder. So zinc oxide's a powder, so it had to be a solid. Hydrochloric acid you've used since year 7, so you know it's dissolved in water, hopefully, which is the symbol aqueous. And you're told that zinc chloride, this stuff here, is a solution. And of course, water, you should know, is a liquid. Right, so that's that one. 2 marks. For those, you get 1 mark if you get 2 or 3 of them right. 2 marks if you get them all right. Give one way that the student could speed up the reaction. So this is thinking about rates of reaction really now, but basically if you heat it up or increase the concentration of the acid, you would increase the rate. It might be tempting to say, well, you could increase the surface area, but it's already a powder, so you can't do that. And there isn't a catalyst for this reaction, so you can't mention a catalyst, unfortunately. If you just increase the volume of acid, that doesn't work either, because remember the factors which affect rate of reaction are changing concentration, temperature, catalyst and surface area, 2 of which we've eliminated this time. Volume is not one of the things that affects rate of reaction. You just get more of stuff if you increase the volume. So increased temperature is one way of getting the mark, or increased concentration of acid is the other way of getting the mark. Hydrochloric acid was limiting reagent. Now, to be honest with you, we haven't done limiting reactants yet. It just means that there's less of it than there is zinc oxide. But how would you? All that means, therefore, is that all of the acid is going to get used up before all the zinc oxide is used up. And I'm sorry we haven't covered that before doing the paper. But the question, really, you don't need to understand that to be able to answer this question. So how can the student know when all of the acid has reacted? Well, this you have done when doing the copper oxide practical. So this is exactly the same as the copper oxide practical that you've done. You might remember taking a black powder and adding copper sulfate to it. And the idea is you, to get rid of the copper oxide, which was in excess, you filter it to remove it. And you can do that now. So what you find is that you know that all the acid is reacted because there is some zinc oxide remaining. That solid powder, that white powder, still floating around. So solid, you could say solid remaining, or you could say zinc oxide is remaining, and so on. Okay. It doesn't allow it in the mark scheme, which I think is annoying. But one thing you could say is check the pH has gone to 7. I'll tell you why it's not in there. Check the pH is not less than 7. It's because you need a tiny bit of acid to make it pH less than 7. It's just a possibility that it'd be hard to tell, but that really, I think it's mean that they haven't given that as an option, as a mark. Anyway, question 4.4, to get rid of the solid. And if I told you how do you get rid of sand from water, you'd all tell me filter it. It's exactly the same idea. How do you get rid of all of the zinc oxide that's remaining? Well, you filter it. And that's all you have to say, filtration or filter. Would have done a job there. What's slightly more difficult is how do you get zinc chloride crystals from the solution? So now sometimes we get confused because we've seen chemicals we're not familiar with, and this is what happens in the exam paper. They'll ask you about things that you know about, but you won't recognise them because you haven't maybe, or were not familiar with that particular compound. But if I told you that I was going to give you a glass of salt water or seawater, say, which is salty water, how would you get salt from it? All of you would say you simply evaporate the water from it and you're left with crystals of salt behind. So how would you do that in the lab? Well, probably what you do properly, if you're doing it properly, is put the zinc chloride in an evaporating basin. and you'd balance that on top of a beaker of hot water, and you'd heat that beaker, and you'd heat this beaker, which would heat the solution in an evaporating basin. The water would evaporate, and you'd be left with the crystals of zinc chloride, and you've done exactly that with copper sulfate. All you need to say for the mark here, though, is heat, tick, and then you heat it really until you evaporate half the solution roughly, or until it starts to crystallize. But then for the second mark, you leave to crystallize. One possibility. You don't need to get rid of all of the water, but you could also say just allow it to cool. That's the two options for getting the second mark there. Again, you've done that in the lab, just recognizing that this question is testing the skills you learnt in that practical. As I mentioned at the start, acids and alkalis, so hydroxides are always alkalis. They react to give sodium sulfate, and they'll give water as well. Sulfuric acid is added gradually. The pH is going to change as sulfuric is added until you've got it in excess. In other words, you've got more of it than you have sodium hydroxide. So the pH at the start is when there's only going to be sodium hydroxide in there, and you should know that that's a strong alkali, and the pH is going to be anywhere between 12 and 14. So a very high pH because you've got sodium hydroxide. If you add the acid, it will neutralize the sodium hydroxide until you get to pH 7, but then it does say you're adding until it's in excess, and so you're going to end up with lots of acid in there, and the acid pH is going to be somewhere between 0 and 3 probably, and that's due to excess of sulfuric acid. Now, to balance this equation, I think this question is quite hard. A lot of you will have struggled with this, and I wouldn't be overly worried. I'd like you to be able to do it though. The way to do it is to recognise that sulfate is a 2- ion. This is just a fact that should be in your revision cards and your flashcards. And you can work out the sodium as a 1+ ion because it's in group 1 of the periodic table. So when it forms an ion, it loses that 1 electron in the outer shell, making it 1+. So sodium sulfate must have a formula of Na2SO4, and that's the first point. If you didn't get that, you had no chance really. And sodium sulfate, the salt, the reason it's this formula is because the compound, the salt, needs to be neutral overall. It needs to have a 0 charge. You've got a 2- charge here, so you need 2 pluses, so you have another Na+. You've got 2 pluses and 2 minuses, so that's the formula of the compound that you get. And any neutralization between alkali and acid, you get water. And so all you then have to do is balance the equation. So we've got 1 sulfur, we've got 2 sodium, so we need a 2 there. Let's see if this is balanced now. Don't think it is, but we've got 2 sodiums, good. 1 sulfur, good. 1, 2, 6 oxygens, and 1, 2, 3, 4 hydrogens. So the way to balance that is stick a 2 there, and it's suddenly balanced. You can tot it all up in the way that you normally would, just count how many there are of each element. A solution of hydrochloric acid had a hydrogen ion concentration of 1 mole per litre. This won't mean all that much to you, because we haven't done anything about moles yet, but you need to know this is a measure of concentration, and you're told that in the question, so you could have worked it out, and that's why I don't feel guilty about putting it in your mock paper. What you need to know for the acids topic, and if you didn't get this question, this is the thing you don't know, is that when you dilute an acid by 10 times, you get a 1 unit pH increase. So as you go from pH 1 to pH 2 to pH 3 to pH 4, that's 10 times more dilute. Or if you go the other way, it's 10 times more concentrated. So you're told you've got a hydrogen ion concentration of 1 mole per litre, and you're told that the pH increased by 1. So it's gone from pH 1 to 2 or 2 to 3 or whatever it might be. It means you've diluted it by 10 times. So you've gone from 1 to 0.1. Quite a tricky question for 1 mark, I think. Let's take a break.